Welcome to Mile Microscope. Today we turn our attention to a phenomenon both powerful and enigmatic, the polar vortex. High above the icy plains of the Arctic and Antarctic, a swirling mass of cold air circles relentlessly. This is the polar vortex, a vast atmospheric gyre bound by a delicate equilibrium of temperature and pressure. Join us as we descend into the heart of the polar vortex to understand its workings and unravel its growing influence on our world. In the Earth's atmosphere, where frigid air collides with the warmth of the lower latitudes, a remarkable phenomenon takes hold. This is the polar vortex, a vast low-pressure system that encircles both the north and south poles. Held in place by the Coriolis effect, the polar vortex acts as a giant refrigerator, trapping frigid air within its swirling embrace. Its influence extends far beyond the polar regions, shaping weather patterns across the globe. During the winter months, when the polar regions are shrouded in darkness, the vortex intensifies, its grip on the frigid air tightening. It acts as a barrier, separating the icy air of the poles from the milder temperatures of the lower latitudes. However, this barrier is not impenetrable. Disturbances in the atmosphere can weaken the polar vortex, unleashing waves of frigid air southward. The polar vortex, while a powerful force, is not invincible. Its stability relies on a delicate balance of atmospheric pressures. One of the key players in this atmospheric ballet is the jet stream, a high-altitude river of wind that flows around the globe. The jet stream acts as a boundary between the cold air of the polar vortex and the warmer air to the south. However, the jet stream is not a static entity. It meanders and shifts, influenced by factors such as temperature differences in the atmosphere. When these differences are less pronounced, the jet stream can weaken, allowing the polar vortex to bulge southward. Imagine a dam holding back a reservoir of icy air. As the dam weakens, the reservoir begins to leak, sending surges of frigid air spilling southward. These surges can bring record-breaking cold temperatures to regions unaccustomed to such extremes. In January of 2019, the United States experienced firsthand the chilling power of a disrupted polar vortex. A mass of frigid Arctic air surged southward, engulfing a vast swathe of the country in record-breaking cold. From the Great Lakes to the Gulf Coast, temperatures plummeted, plunging millions into an icy grip. Cities accustomed to mild winters found themselves battling sub-zero temperatures, while snow and ice brought transportation to a standstill. Schools and businesses were forced to close as the extreme cold posed a significant threat to human health. The economic toll of the event reached billions of dollars, a stark reminder of the disruptive power of extreme weather events. The 2019 cold wave serves as a stark example of the potential consequences of a destabilized polar vortex. The polar vortex, though geographically confined, is not an isolated phenomenon. It is a conductor in the global orchestra of weather, its influence felt far beyond the polar regions. One of the key ways in which the polar vortex influences global weather is through its interaction with the jet stream. A weakened jet stream can allow the polar vortex to expand southward, bringing cold air to lower latitudes. Disturbances in the jet stream, caused by factors such as warm air masses moving northward, can also disrupt the polar vortex, causing it to weaken or even split apart. These disruptions can have cascading effects on weather patterns across the globe. Understanding the complex interplay between the polar vortex, the jet stream, and other atmospheric factors is crucial for predicting and preparing for the impacts of a changing climate. As our planet warms, the delicate balance of the Earth's climate system is being disrupted. Climate change is having a profound impact on the polar vortex. The Arctic is warming at twice the rate of the rest of the planet. This weakens the jet stream, allowing the polar vortex to expand southward. We may see more frequent and intense extreme cold weather events. The relationship between climate change and the polar vortex is complex but significant. The consequences of a disrupted polar vortex extend far beyond a few days of unseasonably cold weather. These disruptions impact human health, infrastructure, agriculture, and the economy. Extreme cold can lead to hypothermia and frostbite. Infrastructure strain can be immense. Power grids can be overwhelmed, leading to blackouts. Frozen pipes can burst and transportation can be crippled. Agriculture is highly vulnerable. Crops can be damaged and livestock can perish. Economic impacts affect tourism, transportation, energy and retail. Investing in adaptation strategies is crucial as climate change intensifies extreme weather events. The story of the polar vortex is not just a tale of modern-day weather phenomena. It's a story woven into the very fabric of human evolution, shaping the destiny of our species and our ancient relatives. Millions of years ago, long before the rise of modern humans, the Earth was in the grip of an ice age. Vast ice sheets covered much of the northern hemisphere, and the polar vortex, even more intense than it is today, played a pivotal role in shaping the lives of the creatures that endured those harsh conditions. Among those creatures were the Neanderthals, our closest extinct relatives. The polar vortex, with its influence on temperature and precipitation, would have played a crucial role in shaping the Neanderthals' world. Understanding how ancient humans adapted to the challenges posed by the polar vortex can provide valuable insights into our own resilience and adaptability in the face of a changing climate. While the polar vortex wreaks havoc with its icy breath, another consequence of climate change is quietly but relentlessly reshaping our planet rising sea levels. The culprit, the relentless melting of glaciers and ice sheets driven by the warming of our planet. As temperatures rise, glaciers and ice sheets, once steadfast guardians of Earth's frozen reserves, are shedding their icy burdens at an alarming rate. This meltwater flows into the oceans, causing sea levels to rise inch by relentless inch. Coastal communities, home to a significant portion of humanity, are on the front lines of this slow-motion inundation. As sea levels rise, coastlines erode, storms surge further inland, and low-lying areas face an increasing risk of permanent submergence. The economic toll is staggering, as coastal infrastructure faces increasing risks from erosion, flooding, and storm damage. The rising tides serve as a stark reminder of the interconnectedness of Earth's systems. While the polar vortex dominates the polar regions, another climate phenomenon, El Niño, exerts its influence from the tropical Pacific, disrupting weather patterns and impacting ecosystems far and wide. El Niño, characterized by unusually warm surface waters in the central and eastern tropical Pacific Ocean, is part of a natural climate cycle known as the El Niño Southern Oscillation, or ENSO. This cycle, oscillating between El Niño and its cooler counterpart, La Niña, has far-reaching consequences for global weather patterns. During an El Niño event, the warmer-than-average waters in the Pacific disrupt atmospheric circulation patterns, altering the jet stream and influencing the track of storms. The result? Shifts in rainfall patterns, bringing droughts to some regions and floods to others. The impacts are felt across the globe. In some regions, El Niño brings much-needed rainfall, replenishing reservoirs and boosting agricultural yields. In others, it brings devastating droughts, scorching crops, fueling wildfires, and exacerbating water shortages. Understanding El Niño and its impacts is crucial for predicting and preparing for climate variability and change. As our planet navigates the uncharted waters of a changing climate, the polar vortex stands as a symbol of the complex and often unpredictable consequences of our warming world. Its behavior, once relatively stable and predictable, is becoming increasingly erratic, influenced by the warming Arctic, melting ice sheets, and shifting atmospheric circulation patterns. The future of the polar vortex is uncertain, but one thing is clear: its influence on our planet's climate is only likely to grow in the coming decades. As the Arctic continues to warm at an alarming rate, we can expect to see more frequent and intense disruptions to the polar vortex, leading to more extreme weather events around the globe. The consequences of these disruptions are far-reaching, impacting human health, infrastructure, agriculture, and the economy. The challenge before us is immense, but not insurmountable. By understanding the science of climate change, investing in renewable energy, reducing our carbon footprint, and adapting to the changes that are already underway, we can create a more sustainable and resilient future. As we've journeyed from the icy plains of the Arctic to the sun-drenched tropics, we've witnessed the intricate connections that bind our planet's climate system. The challenges posed by climate change are real and urgent, but they are not insurmountable. By understanding the science, embracing innovation, and working together, we can create a more sustainable and resilient future for all. Thank you for joining us on this exploration of the polar vortex and its impact on our world. Together we can make a difference.